Picture this. You're gazing at the night sky, admiring our familiar moon. But what if I told you that Earth might have a second companion? Not a full-fledged moon, but a mysterious tiny rock trailing in our orbital path. Curious about what's really out there? Subscribe now and stay tuned. We're about to uncover another mind-bending story from our cosmic neighborhood. On August 29, 2025, the telescope survey Pan-STARRS at Haleakala Observatory, Hawaii, captured a faint object moving with an unusual orbital signature. After analyzing both new and archival data, astronomers concluded that this object, 2025 PN7, may have been in Earth's orbital vicinity for around 60 years already, and could remain for another 60-plus years. Here are some headline facts. Estimated diameter, about 1530 meters, 5100 feet. Very small by astronomical standards. Orbit, semi-major axis about 1.03 AU, almost identical to Earth's. Classification, it's an Apollo group asteroid, but with a co-orbital resonance with Earth, meaning it shares Earth's orbital period around the Sun. Crucially, it is not a true moon. It orbits the Sun just like Earth does, but in a way that from our perspective makes it look as though it is trailing or companioning Earth. Astronomers call such objects quasi-satellites or quasi-moons. To understand 2025 PN7, we need to define a few terms. A moon typically is a body gravitationally bound to a planet, orbiting it directly. Our moon is a perfect example. A mini-moon is a small object temporarily captured by Earth's gravity and orbiting Earth for a short time, months or years. But a quasi-moon is different. It isn't gravitationally bound to Earth in the same way. Instead, it shares a similar orbit around the Sun as Earth, often in a 1.1 mean motion resonance, making it appear to circle Earth from our vantage point. From its own frame of reference, 2025 PN7 orbits the Sun, but because its orbital period matches Earth's nearly exactly, it remains near Earth in a kind of synchronized dance. To what's more, some quasi-moons follow horseshoe or tadpole-shaped paths relative to Earth, slowly shifting ahead and behind over decades. Because 2025 PN7 is small, faint, and has limited visibility windows, it evaded detection for decades. Researchers say it's the smallest and least stable quasi-satellite yet identified for Earth. Let's zoom into the orbital mechanics of 2025 PN7. Its semi-major axis is 1.03 AU, very close to Earth's 1000 AU. Eccentricity, about 0.108, meaning its orbit is mildly elliptical. Inclination just pseudo, so it stays near Earth's orbital plane. The models indicate it may have been in this co-orbital configuration for 60 years and could continue for another 60-70 years. Some modeling puts the total possible quasi-satellite lifetime at 128 years. What does this mean practically? It means this tiny rock is pacing Earth around the Sun, sometimes leading, sometimes trailing, but never fully captured like our moon. Also important, though it follows Earth, it is not inside Earth's Hill sphere, the region where Earth's gravity dominates. It remains outside, meaning it is not gravitationally bound in the conventional sense. Why should we care about this tiny rock following us? Several reasons. Do natural laboratory for orbital dynamics. Because 2025 PN7 is in a 1.1 resonance with Earth. Studying it helps scientists understand how objects get captured into and escape from these near-Earth co-orbital states. This sheds light on the broader population of near-Earth objects. Accessible target for exploration. Because its orbit is very similar to Earth's, the delta V, the fuel cost to reach it might be lower than many other near-Earth asteroids. That opens up possibilities for future missions, robotic or sample return, or even asteroid mining scenarios. 3. Planetary defense context. Although 2025 PN7 poses no known threat to Earth, observing and tracking such objects improves our models of how debris and asteroids behave, and thus helps refine impact risk assessments. 4. Clues to solar system history. Some studies suggest that near-Earth quasi-moons may in fact originate from lunar ejecta, material thrown off the moon by impact, or from the main asteroid belt. Understanding these origins influences our understanding of material exchange in the Earth-Moon system. With such a discovery, media headlines often explode with phrases like, "Earth has two moons." But that's misleading. The science-correct version: Earth has one true moon. This object is a quasi-moon, not a new moon in the conventional sense. Let's unpack common misconceptions. Myth: 2025 PN7 will crash into Earth. Reality: no current threat. The orbit doesn't indicate imminent collision. The it will stay forever. Reality: likely only decades before solar and gravitational perturbations push it out of this resonance. Myth: it looks like our moon. Reality: at Shocker 15 or 30 mm diameter, it's tiny. You wouldn't see it with bare eyes, and it doesn't illuminate the night sky like our moon. This combination of fascinating science plus public confusion makes 2025 PN7 a great case study in how astronomy intersects media and perception. What's next for 2025 PN7 and for us? Tracking and characterizing. Scientists will continue to observe its orbit, refine its trajectory, and try to determine its composition via spectral analysis, radar imaging, or future missions. Because it's so small and faint, magnitude 26 observations are challenging. Future missions. With technology advancing, missions might target quasi-moons like this one, leveraging the Earth-like orbit to reduce cost and mission complexity. This could accelerate asteroid science, resource extraction, or even test technologies for Mars missions. Discovery of more companions. Astronomers believe there are likely many more quasi-moons or co-orbital asteroids waiting to be discovered. With new surveys, e.g. the Vera C. Rubin Observatory coming online, the next decades may bring a flood of such finds. Public engagement. Objects like 2025 PN7 capture the imagination, reminding us that even in our own celestial backyard, surprises remain. Keep watching the skies and keep asking questions. So next time you look up at that big bright moon, remember, you might have a silent, much smaller companion in the dance around the sun. One that's been with us for decades and may stay for a few more. Stay curious and keep exploring. Thanks for watching. Subscribe for more space stories